Steelhead and rainbow trout are the same species, Oncorhynchus micus. A steelhead isn't a separate fish, it's a rainbow trout that went to the ocean. Scientists have identified a chromosomal inversion on chromosome OMY05, a region of the genome sometimes called the migration supergene, where the ancestral form of the inversion is linked to the anadromous life history and the derived form is linked to residency. In coastal California populations, the signal is particularly strong, but the genetics alone don't determine the outcome. The current best supported model is called the conditional strategy. Fish don't inherit a fixed rate at birth. Instead, the decision appears to be probabilistic, driven by an interaction between genetic predisposition, individual growth rate, body condition, and environmental conditions during the juvenile stage. Fish with higher metabolic rates and faster early growth are significantly more likely to undergo ocean migration. The ocean is essentially a bet on growth, and it only pays off for fish that survive the migration. The data shows it pays off more for some fish than others. Juvenile females are more likely to smolt and go to sea than males. The reason is reproductive math. Female fecundity in salmonids scales steeply with body size. A larger female produces exponentially more eggs. The ocean investment has a higher expected return for females. Males can reproduce at a small size using what researchers call the sneaker tactic, fertilizing eggs without competing directly for spawning position. So the growth incentive to go to sea is lower. Transformation that makes any of this possible is called smoltification. A juvenile fish committing to ocean migration undergoes a complete physiological overhaul. Its body turns silver, its fins darken, and at the cellular level, its kidneys and gill cells restructure to process saltwater instead of freshwater. The trigger is a combination of increasing photoperiod, rising water temperature, and reaching a critical threshold body size. A fish that doesn't hit that size threshold before the migration window closes stays in the river and may stay permanently. Size at ocean entry also determines marine survival. Larger smolts entering the ocean survive at significantly higher rates than smaller ones. The ones that make it back are the ones that are going to be big enough to smolt and big enough to survive the transition. The ones that return to spawn can be 3 to 5 times larger than their siblings that stayed in the same stream. And that size difference comes entirely from 2 to 4 years of feeding in the Pacific. Two offspring from the same parents in the same river can end up as completely different animals. One, a 12-inch streamfish, the other, a chrome 20-pound ocean runner. Same genetics, same water, different decisions made by a juvenile fish based on its own body condition against a genetic threshold nobody has fully decoded yet.